Welcome back, viewers. It's been awesome with the topic set theory so far. Now, if you look at the videos, we've looked at definition of sets. We've also looked at types of numbers, forms of sets. Now, the types of number helped us to list the elements of sets. We have equally learned, as far as this set is concerned, the Venn diagram. We've also learned symmetric difference of sets. And the last thing I want us to look at, as far as set theory is concerned, is what I title the Cartesian product of sets. So, it is very simple. I'm going to simplify this within the next few minutes. Let's get started. We said that given two sets, A and B, the set A, B, which is the same as B, A, is called the pair or unordered pair. Here, the order of listing is not important. But if the order of listing becomes important, we introduce a new kind of bracket, which is this. Then the set A, B is not equal to the set B, A. We say this is called an ordered pair. All that is grammar. Let me simplify all these things that I've written down here. So, remember, we say that if you have a set, say A, B, C, and so on, that this is also the same thing as writing B, A, C. In other words, remember we said in a set that the order of arrangement does not matter. So that means that this set is equals to this set. So we are saying that if the order of arrangement does not matter as far as a set is concerned, then we say that this is a set of unordered pair. Unordered in what sense? The order of importance does not matter. Now, if the order of importance becomes very important, then we are looking at something different entirely. And that's where I'm taking us to right now. So, that's by the way. Now, if I have something like this, A, B, and I have something like this, B, A, this is not equals to this. Unlike using a curly bracket where A, B was the same thing as B, A. This is a set of unordered pair. But this is a set of ordered pair. In what sense? The order of arrangement is taken into consideration. That's to say, it's very important. Now, in the Cartesian coordinates, for if you have done graph before, in the Cartesian coordinates, when you are plotting your graph, you will always say that this is A, B. In other words, you can have something like 3, 5. In plotting this graph, you will agree with me that this is the x coordinate and this is always the y coordinate. So this is the x coordinate, this is the y coordinate. It can never be otherwise. Y cannot come first and y cannot come first and x cannot come second. It is always x and then y. So the order of importance really matters. All right. So back to where we are. So we say that when we consider the order of importance, now when you are using these curly brackets, the order of arrangements is not important. But when you are using this particular bracket, then the order becomes very important. So it must be A, B. It cannot be B, A, like in this case. So we're only considering the fact that it must be A, B. Then when that happens, we now say that, okay, that this is a set of ordered pair. So if you read this again, you really understand what I'm trying to say. So we say that the set A, B is not equal to the set B, A, cannot be equal because of this particular bracket we are using. So we say that this is called a set of ordered pair. So now, if I have a set A to be maybe A comma B, and I have another set B to be 1 comma 3. Remember, because of this bracket, we are saying that this is a set of ordered pair.
Mathematics tutorial with Emma Johnny.